Through the last century, there's been a great achievement in the biochemical understanding of the body. And though the breakthroughs are great, there's been some huge gaps that need to be explained. Would you like to expand on those?
There are gaps, and they're not going away, and this is a good time to look at the gaps in our knowledge. And the gaps are apparent because we have two different disciplines. One is physics and one is medicine. And I don't think they have morning tea together. And they've grown apart, we could put it that way. And they don't feel as if they need to make an explanation in physics terms, because the medical people have got a self-contained model that's basically biochemistry and not much physics.
What are some of the fundamental differences between what biochemistry can explain and what a bioenergetic model can explain?
Well, that's a very explosive question, very early on. And let's look at the things medicine isn't very good at explaining. First of all, we've got a body. We all learn about bodies with its structures, and we've got big structures, little structures. We come down to the cell, which has a metabolism, and inside the cell, we keep going in, there's DNA. And the DNA is being proposed at this minute as the way in which the body structures itself and organises all those billions of processes that go on in the cell, in the billions of cells every second, from the moment you're born until after you die. Now, what is the overall way in which the body regulates itself? How does it regulate its temperature inside and out the body, night and day, summer and winter, to within 1 degree centigrade change? How does the body regulate its blood pressure, even though there's a million different arteries of different diameters? How does the heart manage to get the blood to come back to be pumped? These are just a few of the monstrously difficult questions that you can't actually explain very satisfactorily with biochemistry.
So would it be fair to say that one of the most critical problems in biochemistry is that it has no way of explaining information transfer in biology?
Well, it would be unfair to say they haven't tried, because from 1955 onwards we have the genetic model, which is basically, you see pictures of the DNA and it's a spirally arranged complex molecule, the twin spiral. And mind you, they know there's a problem in explaining how we regulate ourselves and what's the cause of disease, you know. People say to them, oh, why am I sick? Don't know. And so the DNA is a biochemical model. And in that we've got bonds and we've got receptor sites and the way in which things are structured in a chemical idea of a universe. But you go to physics and everything, the particles are empty space. There's a lot of empty space there.
So would it be fair to say that you need physics to explain chemistry? Because at the moment they've got a biochemical model of which they...
The whole chemical idea was constructed without physics on its own to make a sort of a mechanical view of the universe. And so the chemistry department doesn't talk to the physics department, the physics department doesn't talk to the medical department, but we're all in this together. So what we're really proposing at NES is we like the chemistry as far as it goes, but the chemistry inherently creates a field. It creates a structure in space. And whereas chemistry is concerned with energy transfer, which is fine, we are concerned with information transfer so that the body can control, regulate itself, regulate the blood sugar, how much oxygen, the excretion process, blood pressure, temperature, and so on. A lot of the things that go on in higher mammals are incredibly complex and difficult to maintain, and the idea of a chemical explanation isn't on. So we're saying the chemical explanation's all right as far as it goes, but what if? And then to find out how we can get a field information transfer, we've got to go to physics. We can't go to chemistry. So we go to chemistry for the energy transfer, okay? But for the information transfer, we're going to physics, and we've got to go to a certain branch of physics. And of course, the chemical people know how important the electron is in chemistry and the photon. And so we have to look at particle physics to find out what's going on in information transfer and how this works in biology.
Just to identify one of the problems with information transfer in biology, the biochemical model would just say that the nervous system is responsible for this, but perhaps you could explain why the nervous system couldn't actually manage these billions of transactions that must occur every single second in your body.
The nervous system is almost totally discontinuous. A little bit here, a little bit there, and in between the bits of nervous system we have electrochemical systems. And so we've got an electrochemical nervous system which is it can only carry information fairly slowly because there are chemical blocks. Every 6 or 9 or 12 centimetres there's a little synapse, it's a little blockage. And the idea of a nervous system being able to control the body is not really on.
So just for the benefit...
That's a perceptual thing, really. We're talking about where the nerves don't go, to the cell. We're talking about a cellular control mechanism of the whole body. Chemistry can't do that.
This short film basically gives us a new model on how information transfer in biology must be based upon a physics model. Up until this day, there's been 100 years of physics, and we just need to give a brief outline of some of the problems in physics before we outline our new physics model. Would you like to expand on that?
Well, I could expand for a considerable time because we're talking about 70, 75 years of modern physics. They had Maxwell who said, yeah, the photon is a wave. But then they discovered this anomaly in that metallic surfaces seem to put out energy when they get excited. When heated, a metallic surface throws out energy. Yeah. It throws out particles. And how could this be? How can metals in particular, why? And that was answered in Einstein's day quite satisfactorily, and because of that anomaly we got the birth of quantum ideas in physics, that there were packets of energy, whereas waves were considered to be continuous. So we got the packets versus continuity idea, which it doesn't matter as it happens, because the models they had were so wrong. Let me tell you how wrong the model is. For children aged 8 to 12 and older, they always present an orbital with a nucleus with something going around it. And this was never seriously entertained as an idea in physics, and yet it's in every textbook that children, and these are visual models and they stick, and they do put us off the track. So if you forget that, you forget about how on earth we could have an atom bound together by these forces, bonds and shells and so on, and yet the same theory proposed that we had itinerant molecules that would leave the atom and go for a little travel, and then apparently return. How on earth could it return to the same particular atom, or even another one? It was a nonsensical theory, and people have still got these ideas. But why did they have to propose the itinerant electron? Because the electron, before it can interact with another, the electron of one thing has to be able to communicate with the atomic structure, the molecule, of another element before we can get an interaction or a chemical reaction, even a biochemical reaction. So that was the problem, and they proposed this travelling electron that went out and said, oh look, there's a bit of something out there we could react with. We've scrapped all that even since 1940 with Feynman. We need a model of the atom which has lots of empty space and which is flexible enough to allow for information transfer. And all they've got is something that allows for energy transfer. And everything you hear about quantum physics will be about energy. And we're talking about, in biology, in nature, because it's all chemical reactions, we know that, there's got to be a mechanism for one part of the body knowing what another part of the body's doing, and so on.
One of the key failures of particle theory is that it doesn't explain information transfer.
It can never explain information transfer, and it's to the point that they deny that it occurs at a distance. And I think anyone who's been alive and noticed what happens, you get information transfer randomly, it appears, but correctly sometimes, over vast distances. And I think any new model in physics has to take account of that.
In which case, Peter, why does wave theory explain information transfer?
Oh, that's another huge question. Where will I start?
I always give you the
Okay, if you stop thinking about the electron as a particle and just think of it as space, and that it's a spherical wave pattern in space, and there are standing waves. You know, if you've got a big wall and you start throwing a ball, the ball comes back, and it'll make a pattern in space. That's a standing wave. And we're looking at reality of nature, of everything in nature, as just being just that, what I just said. A standing wave that is a structure in space. Now, people think that everything's real and that it's there. Well, we perceive it, but it's actually empty space.
The reason why people have got this attachment to a particle theory is because they think it's something real, and people have got this fear.
The wave isn't real and the particle is.
Yeah, they've got this fear of having a wave vision
The
of
last
reality.
75 years of physics is dogged by people being afraid. They're afraid of the wave idea, so they even say we'll have a wave particle or we'll have a particle. But as it turns out, with the ideas put forward by Feynman and Milo Wolf, we can actually get a spherical wave that is three-dimensional and making standing waves in space. And it's got two parts, it's got two centres which are actually in the same place. But when excited, can move apart slightly. When we excite an electron, we get strange particles appearing for very tiny fractions of a millisecond. And we've got 300 to 400 of these mysterious, it's called the particle zoo by the aficionados. We've got 300 particles that we can't explain. Why are they there? Now, Milo Wolf is a beautiful man because he's saying that if we've got two parts of the electron, each putting out a spherical wave, you'll get interference patterns, and all these 300 or so particle zoo particles, including the photon, are in fact interference patterns. In other words, they have the appearance of reality. Okay. They are appearances, and that means they can appear in two places at once, which has been observed in physics, and that you can get all sorts of odd things happening with time as well.
When you're talking about an out wave and an in wave, because it's quite a difficult thing to people to perceive what actually is going on. So what's an electron doing?
Well, an electron is simply a standing wave in space that is energy arranged in a pattern. You know, if you put a pebble into the pond, you get out waves.
Yeah.
And then when it hits something, it reverses and you come back and you get an in wave. And he's saying that's what happens in nature, and that's how one electron can know in inverted commas, what another electron is and what it's doing.
Because it's everywhere all at the same time?
Well, it appears to be everywhere, but in fact, the electron is in one specific location. We have to know that, or else engineers apparently can't do their bridges. They need to know where things are. That's fair enough.
Or is it more accurate to say the centre of the spherical waves is what's appeared as the...
Beautiful. Milo Wolf says that the centre of the spherical wave is where there's a change in space, density. That is how much energy is there. That is what is the density of space. And the beautiful thing, it's a bit like finding out information by making a noise and waiting for the echo to come back. That's the in wave is the echo, and at the instant of time when the two waves are together in that inner part of the electron structure, that's the information the electron has about its surroundings, and that's what it needs for biochemistry.
Okay. What is the out wave bouncing off to create its in wave?
It intersects with another wave. In other words, the entire universe is constructed of standing waves. This is heresy. It's supposed to be particles and they're supposed to be real. But I'm sorry, we've got a 300 particle zoo of unreal particles and we're dropping it. And Milo Wolf realizes we have to have the texture of reality. So we've got 3 real particles and all the rest are sort of interference patterns. And our 3 real particles are the proton, the neutron, the electron.
But even those real particles in reality are just standing waves.
In reality, they're standing waves in their own right, and they make bonds, they hold together in a structure because of the way they are. That's inherent.
In other words, the electron produces an out wave and an in wave, and the reality that we perceive is the interaction between the two. How does the Milo-Wolf theory relate to our 3-dimensional worldview?
Well, you've got to have 3 dimensions, obviously. The maths is very difficult, but he says in his writing that he can't do the maths. I don't think anyone can. But the concept comes before the maths. But why are we sticking with Milo-Wolf? Because he says that there is energy transfer and information transfer possible in this model. And the way but you've got to have 3 dimensions for this to occur. And this is because
why?
right in the center of that, you know, there's waves going in, waves going out, and there's a central bit which is as if where it all starts from. And that's where all the energy is for that electron, all right? And when these 2 waves intersect, they create a phase difference, so many degrees. And we think the information inside molecules, electrons, carbon, calcium, and so all the biological atoms, of which carbon is possibly king, which has got 4 electrons, so it's very good at transferring 4 bits of information at once. You know, see what I mean? And the information is just a structure in space. It's a picture. It's an angle, you could almost call it a vector. In other words, a 3-dimensional angle.
These 3-dimensional vectors, how does that relate to the NES infoceuticals?
Well, in the research that I did since 1983, I keep coming across things that look like information in biology that we can literally read out of space. Crazy stuff. And it's only when you get the Milo idea of structures in space being the information that we're looking for, you think, well, this is the holy grail of biology. We've found it. Now, it's 3-dimensional. In other words, it makes a little pattern. And these patterns, once you get 2 of them together in the same space, there is a change in the conductivity of space between them. And we've done all our research simply by matching things, and what we're using is a change in the conductivity of space.
So this comes down to a fundamental thing of what the NES device is doing. What it's doing is it's doing a match between your body field and the computer, and it changes the conductivity of space between the device and the
conductivity of space changes at a specific frequency range, not everywhere. And so we can get information out of space and we can put information into space. It's a two-way system. What is happening when you get this information transfer is outside time. It is like a timeless moment. And as far as information transfer instantaneously over long distance is concerned, which some people like Edgar Mitchell think does happen, some important people in science think this should be looked at. And how can this happen? Because as you just said, the structure in space is already there, the waveforms in space already exist. And so information transfer can appear to be instantaneous, even if it isn't. Now, whether or not this is accurate is a big problem, and it may not be. Now, biology wants accurate information. It's got to be really right, or you die. The cell doesn't work, and the cell dies. So we've got, in our model from Milo Wolf, we've got amplitude of the wave. That's the energy component. And that's how big the crest is of the standing wave. That's the energy, whereas inside, back at where the particle is supposed to be, you've got a little set of angles. That's the information. They're in different places.
The NES research is based on matching. We've got an out wave and an in wave, and these both interact, causing a constructive interference pattern or a destructive interference pattern. How does this relate back to matching?
If we're going to match, we want to say, we've got XY here. Are there any other XYs? And because it's a spherical wave going in all directions,
So
we'll say yes.
Out wave of XY.
The out wave will go at a certain amplitude.
Ah, and it hits the out wave of another XY, and you've got it.
Bounces
I
back.
understand it all now.
And then it changes the angle inside, changes that vector inside the electron, and it says, let's get together and make some heat. This is if it's a carbon and an oxygen meeting, you see. Then they react and we get some heat out. Lovely.
Lovely. So
Lovely stuff.
it sounds like we need to go from atoms to molecules to more complex organisms in biology.
You know that it happens with individual electrons and that we get chemical reactions. But guess what? In this sort of physics, it doesn't stop there because structures tend to get bigger and bigger. The same structure can add another one, and when it does, everything changes. And we can get huge structures, okay, representing whole organs, like a heart organ can make a picture in space and transmit it.
Here it gets quite fundamental because it seems that nature is continually matching and simplifying itself to the information that it needs.
The wonderful thing is that nature self-simplifies, and if only politicians would learn to do this. As your structures get bigger and bigger, they have to get simpler. And this is indeed what happens. I've called it aggregation. You keep on adding bits to the match, and it gets actually simpler. It self-simplifies as it goes along. Now, if you keep doing this, you find all of the organs join together and make a sort of a big organ structure, and then you'll get all of the heart and the arteries and blood together. That'll make another big structure. You put them all together in one giant structure and you've got a full body wave. That is you, a picture of you projected into space.
So theoretically, you might be able to correct the whole body wave of a person.
Theoretically, you should be able to read a whole body wave at once, and that's what we think the NES machine is doing.
In which case, Peter, why can't information be found directly? I know in the NES Professional we find it in an indirect manner, but how come no physicist has ever managed to detect QED fields directly?
Yeah, in the early days of radio, it was very high frequency, then we went to ultra high frequency because our detection methods were getting better. And gradually we got right up to 1000 megahertz. Then we got transistors just in the last 10 or 20 years. It would go to 1200 and even 1300 megahertz to detect the electromagnetic energy. And Milo Wolf also asked, well, why can't we find these matter waves, tune them in on a radio? And then you say, there you are, I told you so. This doesn't happen simply because Milo Wolf thinks that the frequency at which they work is about 1,000,000 times higher than light frequencies, visible light frequencies. All right, and visible light is at 10 to the 15 hertz, and so you add 6 for 1,000,000. It's 10 to the 21 hertz. There is no known way we can detect that sort of frequency. So instead, we say, is it like this? Is it like that? And see if we can get it to say, yes, I'm like that, which is a resonance. Yeah, it's bouncing back a standing wave saying, yes, I'm here. I'm a resonance pattern in space.
So we have instantaneous information transfer at a distance, and we've also got a three-dimensional spherical wave. This sounds a bit like a quantum hologram. Perhaps you'd like to tell us about the work of Edgar Mitchell.
Once Edgar Mitchell came back from space, he was a changed man, and people said that he was a bunny hugger. Well, I must be another one because I agree with Edgar Mitchell.
And what was the fun thing he did? He saw something in space, didn't he?
When he was in space, he had a satori, he had an opening of his consciousness. And when he came back, he realized that we needed to know more about consciousness, because what's consciousness? This is what we are. This is who we are, who we think we are. And we can't describe it in any scientific language. In fact, consciousness actually got kicked out of biology a long time ago because it's too hard.
In this model, information is holographic, and even a little bit of the hologram will contain the rest of the information. Why is that so crucial for biology?
Well, we keep on getting explanations for illness about damaged genetics. You've got genetic damage, so you get sick. This is the latest medical theory of disease. And it's all pervasive. People seem to think this is what is happening. And it's part of the story, but there's an awful lot more. If we're talking, how is healing possible? It must be possible if we're constructed merely of intersecting quantum holograms. Quantum holograms is the phrase used by Edgar Mitchell to describe the information that we are and what we live on. And this information gets damaged or doesn't get through, we get sick. Information transfer is incomplete. But Edgar Mitchell and his Noetic Science Institute has evidence to show that if you can get one part of the hologram to work, it reconstructs the rest of it. So healing is possible.
So what you're saying is that every single cell knows what the rest of the body is doing.
That goes back to why we need the theory of the body field in the first place, because every cell of the billions of cells in the body have to know what every other cell is doing at any instant of time.
So Peter, if each and every cell can receive all this information, how on earth, with all the billions of pieces of information that's going on in the body at any one time, how can it distinguish which piece of information it needs?
Well, in any information system, if there's too much information and it's too complex, it has to be categorized. And nature even knows how to make categories. And at NES, we found out there are compartments in space that make categories, and these link to the organs. So the organs, in fact, will work as we only want to deal with this part of the information transfer, another organ does something else. Beautiful. Nervous system does another one. Here's one of the great problems of biology. Nobody can ever explain the semi-permeable membrane. Certain chemicals go through and go into the cell, and some don't. Why is this so? I think they used to say. And it is simply because the in waves and out waves, if they don't self-cancel, it can go in. If it's cancelled, it stops it. That really is a simple way of solving one of the great problems of cell metabolism. And the same kind of process can happen in turn with what temperature should I be, how much heat should I absorb, how much heat should I create, what should I excrete, what is my correct pH. All of this, you see, the cell doesn't have any consciousness. All of this happens automatically.
And it happens automatically because it's matching with what it needs to do. that gets the
Because,
information that,
yeah,
it,
that
that
is
it
simply
matches
a
with.
quality of that outwave.
Here it gets quite fundamental because it seems that nature is continually matching and simplifying itself to the information that it needs to know.
Yeah, very complex systems need to simplify themselves automatically. It just happens as a matter of course.
And the
without
reason
doing
it
anything.
happens is because of matching.
Matching is the key to biology.
And matching is also the key to reality, full stop.
Well, it's your key to consciousness too,
Yeah.
because yeah, it depends what you match to, what your consciousness will be like.
In the NES system, there's 12 energetic integrators that range from sound up to light. How do these affect physiology?
We've already said that the matter wave of de Broglie is filling space in all directions with different qualities, and that it's such a high frequency that it can't be detected by any machine we now have. Well, NES is finding them all over the place. Huge amounts of data. We've got 30 years of data. Now, what we must be doing is picking up the resonances created by those original waves at different frequencies. And the resonances change in character as they go. So we've called these compartments in certain frequencies. This will be the quality of space. At another frequency, the quality of space is slightly different. And in order to help people regain their health, we're simply saying the quality of space in your body should be like this. It sounds mad, affecting the quality of space. But if you don't do that,
But
you don't get the curative effect.
another way of putting it would be the energetic integrators affect the structure of a particular organ, or that they affect the structure of space within the organ.
It's helping all of the chemical reactions to go more smoothly and more accurately once the space quality is corrected for that organ. So we find that all the compartments do relate to organs.
What the energetic integrators do is help correct information transfer in the body.
It helps the biochemical system to return to its normal function without doing any chemistry, without the chemistry.
But in addition, it also helps information transfer in its own right.
Well, chemistry relies on information transfer or it doesn't happen.
If we always need an out wave before we can get the information coming in on the in wave, how does this relate to perception? What on earth is causing the out wave in your senses, like your eyes and ears?
I don't think anyone really knows how eyes and ears work, and we have a story given to us in the books, and you might spend a whole year doing psychology and the theory of perception. But it's a pretty problematical thing, because instead of us perceiving things to be in our head, we perceive them to be outside of us in colour and in 3 dimensions. This is incredible that this is possible. But if you approach it from the idea that the ear actually is sending out, the ear is a transmitter, look at this very complex curls and bits, conchas and so on. The ear is sending out a wave, and then you're listening to what comes back. Your eye is sending out, you know, you look daggers at somebody. People know your eye sends something out, and you get something back. And it's not just the photon, and it's not just the sound wave. In other words, there is a lot more to perception than we thought. And we need this idea of the out wave and the in wave to make perception work.
So your eyes and ears are working like a quantum hologram.
They are there to detect quantum holograms, not to detect sound waves and to detect light. They are perhaps the carrier, they are the medium through which it's done. But the actual information is in the quantum hologram.
Excellent. Okay, Peter, earlier we were talking about the nervous system and how it must be too slow to communicate the billions of processes that occur in the body all the time. How can this new out wave and in wave help biology explain what the nervous system is doing?
The existing model of the nervous system isn't very good because obviously the nervous system carries a lot more information. It doesn't just carry impulses of an electrochemical nature. they're not enough to construct a 3D, you know. We're working in 3D, we're moving all our muscles together in 3 dimensions. Imagine how much information that requires, not just a nerve impulse, either on or off. No, no, no. What we need is a nervous system that can carry information instantaneously, or else we'd all be stumblebums, wouldn't we? We'd be poorly coordinated. Now, all we need the electronic model of the nervous system for is to excite the energy field to allow for more accurate transfer of information. And that's why we have electrochemical impulses in the nervous system. It's as a facilitator. We need light and we need an electronic charge to make this quantum field work.
So what the nervous system is doing is just generating outwaves.
Yeah, it's a structure to facilitate transfer of holograms with the outwave. And you've got the in wave, you've got some types of nerves go in, sometimes go out. You've got an in wave and an out wave constructed into the nervous system in your body. They're called afferent and efferent nerves.
Would you like to explain what an afferent and an efferent nerve is?
We have to take information in from out there and then respond to it. This is what psychology is about. So some nerve pathways take information in from the receptor sites in your skin. We take in information about pressure, heat, and so on. And in response, we send nerve pathway messages out to say, move muscle, move bone, change the tension on this muscle. So there are 2 types, there's in waves and out waves, even in the nervous system, when you start to look.